Hello, we're going to talk about area of kites and trapezoids today. So area of a trapezoid is this formula, 1/2 times the height times base 1 plus base 2. And what I want you to pay attention to is that your bases are going to be one of the, or both of the parallel sides. Right? Remember, in a trapezoid, there's only one pair of opposite sides that are parallel. And then just like in our parallelograms, the height has to be perpendicular to both of those bases. So for example, let's do an example of the trapezoid so we can see how that works. All right, so in this find the area number 1, it's giving us that the perpendicular to both bases, that's our height, that's 10. So I'm going to write that our height is equal to 10, and then that means that 6 and 12 are going to be my base 1 and base 2. And it doesn't matter which one is base 1 and which one is base 2 because we're adding them. So I have enough to do my formula. So I'm going to just plug in what I know. I'm going to plug in H is 10, and my B1 is 6, and my B2 is 12. So now we're just going to simplify this. I have 1/2 still times 10. I'm going to add 6 plus 12 is 18. And then I'm going to multiply all of those together. And that's going to give me 90. So my area is equal to 90. Now for the area of a kite, it's going to look pretty familiar. This looks like the area of a rhombus that we did in our last video. So the D1 and D2 are simply diagonals. So I'm going to have 1/2 times one diagonal times the other. So we've already done rhombus ones that are simple like that. What we're going to do is we're going to make these a little bit harder because we're going to have to find a little more information in order to solve for the area. So in this number 18 here, we know this is a kite because I have 2 pairs of consecutive sides that are congruent. Okay, and so for the area of a kite, I need to know the length of the diagonals. I have to do 1/2 D1 times D2. Well, let's look at what we have. We have the length of this diagonal here. I'm going to be doing 12 plus 8. So that would be 20. So we know that length of the diagonal. However, we do not know how long this diagonal is. So when I don't know how long it is, I'm just going to call it x. And remember that in a kite, it's symmetrical. So I know each of those are going to be the same distance. So I'm going to have x plus x for this diagonal. All right, so how in the world are we going to find what x is? Well, the other thing we need to remember is that in a kite, the diagonals are perpendicular to each other. So what I have here is a right triangle. I'm going to draw this right triangle. So I'm talking about this piece of the kite right here. So this side they gave us is 12. This side they gave us is 13, and we called this x. So if I want to figure out what x is, I'm just going to use Pythagorean Theorem. So a squared plus b squared equals c squared. Don't forget that c squared always has to be that hypotenuse. So that's why 13 is the c squared. So if I multiply that out, I square those numbers and subtract the 144 to the other side. I'm going to get x squared equals 25, which means x is 5. So if x is 5, then I have 5 here and 5 here. That means that the whole diagonal, I'm going to have 5 plus 5 equals 10. All right, so let's plug in what we know. We have enough pieces now to do the area formula. So I'm going to have area equals 1/2. My first diagonal was 20. My second diagonal was a full length of 10. So I'm just going to multiply 1/2 times 20 times 10. And that gives me 100. So notice that we had to do a little bit more extra work with the Pythagorean Theorem. Now 21 and 19, we're going to save those for class. These are also going to require more work, but it's different than the Pythagorean Theorem, so we'll discuss that later. All right, on the back, let's do the area of a trapezoid. And again, I know this is a trapezoid because I have two sides that are parallel, and that's only one pair of parallel sides. Notice that 20 and 16 are not parallel. So I know that the area formula that I'm using is 1/2 times the height times base 1 plus base 2. So if you notice, I don't have a height that is perpendicular to a base. I need something to be right here, right? That's where my height would be. So I have one of the bases, which is 20. All right, but I don't know this full base down here. However, I can find that out. So let's think about this a little bit. When I drew that green line right here, then I created this rectangle and a triangle. So this rectangle means that from here to here is 20, just like from here to here is 20. And then I also know that this is 16, so then I know that this height is 16. So now all I need to do is figure out, well, how much is this part right here? Because I need to find that full base. Right, I want to find that full red length. So I've created another right triangle. And this side is x. They labeled the slanted side as 20. And we just said that the height is 16. So I'm going to use Pythagorean Theorem again. I'm going to do a squared plus b squared equals c squared. And again, remember that c squared has to be the hypotenuse, which is 20. So if we square those numbers and subtract the 256 to the other side, and then take the square root of both sides, I get x equals 12. So I know that this length right here is 12. So that makes this whole base along the bottom, it's going to be 12 plus 20, which is a total of 32. So let's write what we have. So we have our height is 16, our base 1 is 20, and our base 2 is 32. So I have all the pieces I need to do my formula. So I'm going to plug in the h and the b1 and the b2. I'm going to simplify the b1 plus b2 to be 52. And now we can just multiply those numbers together to get 416. So that is my area of the trapezoid, and again, we had to do a little bit more work in order to find that. All right, so these last two, we're finding the missing dimension, so notice that they're going to be giving us the area. So this is the area of a trapezoid, so I know this is my formula. All right, the x is my height, 21 is my base 1, 28 is my base 2, and then this is my area, my A. So I'm just going to plug in those numbers where they belong. All right, so let's simplify this a little bit. Remember, we're trying to solve for x. So I'm going to add the 21 and 28 together to get 49. Now remember, when we have a bunch of things multiplied together, I can multiply these two things together first. I don't have to do 1/2 times x first. So 1/2 times 49 is simply 24.5, and I still have x, and I'm trying to solve for x, so I'm going to divide by 24.5. So I'm going to get x is equal to 8. So that worked out nicely. It's simply 8. All right, and then the bottom one is another trapezoid. So again, we're using the area formula that we know. And we're going to label what pieces we have here. So I have the height here that's perpendicular to this base. So 17 is my h. The area is the 187. 6 is my b1. And then x, my unknown, is b2. So let's plug that in. I have 187 equals 1/2 times 17 times 6 plus x. So if I simplify that, I'm going to do 1/2 times 17, which is 8.5. And then I have 6 plus x. And now I'm going to distribute. So I'm going to distribute the 8.5 to those parentheses. You could also divide the 8.5 at this point if you wanted to. So 8.5 times 6 is 51. And now I can subtract the 51 to the other side, and that gives me 136. And then if I divide both sides by the 8.5, I get 15.81. So x is a really weird number, 15.81, but that's what that base is. So we will come back to those two on the front in class.